Okay. So when it comes to balancing, you're already given the reactants and the products. So reactants are O2 and SO2, and they react to produce SO3, right? So that information is given. You don't have to know what products we are getting from certain reactants. That will be given to you. Okay. So here are my reactants. Here are my products. All I do is count the atoms. We have how many sulfur atoms on the reactant side? One. How many on the product side? One. So I'm not gonna touch sulfur. Okay. Oxygen. How many on the reactant side? Four. How many on the product side? Three. So I want to have three on the reactant side as well. So I'm going to halve my O2. Now I have three oxygens on the reactant side as well. But I don't want to have fractions in my final balance equation. So I'm going to multiply everything by 2. When I do that, I'm going to get 2 here, and this 2 will cancel out, and I'm going to get 2 here. So this should be my final balance equation. Right. Any questions, concerns, comments about balancing equation? This particular equation? Anything? Okay. But once again, so you might have your own way of balancing equations. If it works for you, please, feel free to use them. Hi, Dylan. Okay. But, this is the way I do it. I just want to show you how I do it. And then whatever works for you, you should run with that. All right. Now, the next question is the limiting reactant. Okay. So I think most of us said SO2. Let's see. I mean, we have 50% chance of getting this right. Okay. But that if we gamble, but we don't have to gamble. Okay. So let's see. What I'm going to do is this. I'm going to write the balanced chemical equation once more. Okay. SO2, O2, SO3. We saw that we're going to get 2 of each. Okay. So according to the balanced chemical equation, let me clear my doodling first. Now I want you to tell me, so to react with 2 molecules of SO2, how many molecules of oxygen do we need? According to the balanced chemical reaction. With 2, how many reacts? How many oxygen molecules react? 7? Yeah. Okay, one more time. Okay. So I'm asking this. Okay, you have a balanced equation in front of you. My question is, to react with 1 SO2 molecules, how many molecules of oxygen do we need? 1, right? Yeah, because it's in front of us. So with 2 SO2s, only 1 oxygen reacts, right? Okay. Now, here's the thing. We have not 2, but let's count. We have 1, 2, 3, 4. Oops. 1, 2, 3, 4 SO2 molecules, right? So to react with 2, we need 1. To react with 4, how many oxygen molecules do we need then? Thank you. But I see some hands. What do you guys think? So to react with 2, we need 1. To react with 4, we need 2. Thank you. Said twice that, right? So we need 2. This is what we need. But how many do we have? We are told that we have 1, 2, 3, 4 oxygen molecules. Okay, so we have 4. This is what we have. We have more than what we need, meaning oxygen cannot limit our reaction because we have more than what we need. Therefore, SO2 has to be our limiting reactant. This should be my limiting reactant. Okay. All right. What questions, concerns, comments do we have? All right. The limiting reactant is all about what we need versus what we have. Okay. It's not about what reactant is in, do we have more? Okay. It's about the need. Okay? You should always consider the need. Okay. It's like this. Here's the analogy. Say that you are baking a pumpkin pie. Anybody? All right. Here's my recipe. Okay. So you use 100 grams of pumpkin and 300 grams of sugar. Okay. That's okay. So that's what you need, right? That's our recipe according to the recipe. Now you go to, I don't know, Safeway or Albertson or Fry's or somewhere, and then you buy 100 grams of pumpkin, but only 200 grams of sugar. What is limiting our pumpkin pie make actually? Sugar. Even though we have 200 grams or more sugar than pumpkin, sugar is still limiting. Why? We need 300, but we only have 200. Yeah? So keep that in mind. By the way, if you make a pumpkin pie using my recipe, okay, I have license rights, okay? You have to bring a piece to me. Okay. All right. Anyway, do we have any questions? Yes, sir. How many oxygens?
Like when you're explaining how many oxygen.
Okay. So need, right? Need is what is given, what is dictated by the recipe. Okay. So to react to bake with 100 grams of pumpkin, we need 300 grams of sugar. That's the recipe. Okay. Like that, this is our recipe. Our balanced chemical equation is our recipe. Okay. According to that, we react with two SO2 molecules. How many oxygen molecules do we need? One, right? To react with two, we need one. To react with four, we need two. That's what we need, but we have four, so we have more than what we need. That means oxygen is not limiting, SO2 is limiting. Yeah? Wonderful. Any other questions, concerns, comments? Okay. Now with that, let's do this. I'll reopen the question in case somebody wants to revise the answers. Oh, by the way, we have a balanced chemical reaction for this. You're gonna need that. You will be given, the balanced chemical reaction, or maybe the chemical reaction at least, so that you can balance it. So when CH4 reacts with oxygen, it produces CO2 and H2O. Okay. So we have one carbon, four hydrogens, but two here. So I'm going to multiply this by two. Now I have four oxygens here, only two. So I'm going to multiply this by two. Here's my balanced chemical reaction. Okay. So you're going to need that. Okay. Now here's the thing. Okay. So when it comes to reactions like this, the limiting reactant is going to call the shots, because limiting reactants will determine how much products we get all the time. Okay. So now, which one is the limiting reactant, CH4 or oxygen? Come that again? CH4. How do you know that, Thomas? Yeah, so you're literally told that oxygen is in excess, right? CH4 was burnt in excess oxygen, meaning oxygen is in excess, it cannot limit our reaction. Okay, therefore, limiting reactant is CH4, that calls the shots. So that is something to keep in mind. Anyway, so it's really simple. I mean, at that point, now according to the balanced chemical reaction, if you had 1 mole of CH4, let me use a different color, I'm sorry. Let me use molecule, mole, they mean the same. Let's say you have 1 mole of CH4. How many moles of water do you get? With 1, you're going to get what? With 1, you're going to get? Everybody, please. 2, right? With 1, you're going to get 2. But you have 10, right? So with 1, you're going to get 2. With 10, you're going to get how many? 20. That's it, you're done. It should not take more than 30 seconds. Yeah? That's all you have to do. Okay, so this is how we use these stoichiometric coefficients to solve these problems. They're really, really simple. All right, what questions, concerns, comments do we have? Any questions, concerns, comments at this point? We'll do that, maybe some problems that requires calculators, but for now you can see, it's really simple once you have a balanced chemical equation in front of you. Okay. So let me do this. Okay, most of us got there, but anyway, I have reopened the question in case some of you want to resubmit your answers. But for now, I'm going to move on to the next question. Same chemical reaction. This question, I have more than 90% now. Okay. I'm going to close this question in 5, 4, 3, 2, and 1. And okay. So we are mainly between B and C. I have a feeling one of them is correct, not both of them. Okay. All right. Let's see which one is correct. Okay. So one more time. The limiting reactant calls the shots. You need to figure out which one is the limiting reactant out of the two reactants. Okay. So how do we do that? So to react with 1 mole of CH4, how many moles of oxygen do we need? 2. Thank you. Okay. Now, did you notice that I somehow switch from molecules to moles? You can really do that. Okay. So I can interpret these equations or stoichiometric ratios as like a molecule ratios or molar ratios. They have the same meaning. Okay. So with 1 mole, you're going to need 2 moles of oxygen. But we are given 25 moles of CH4. Okay. To react with 25 moles of CH4, how many oxygen moles do we need then? We need 50. Thank you. We need twice that, right? We need 50. This is what we need. Okay. So we need this much, but what we have is only 25. Meaning we do not have enough of oxygen. Therefore, oxygen is our limiting reactant. This is our limiting reactant. That's the first thing you are going to do. Okay. Now, once you have that, you are going to look at the relationship between your limiting reactant and what they're asking. They're asking for the moles of carbon dioxide, right? So now you can see that between oxygen and carbon dioxide. Let me rewrite that just for fun. I'm going to rewrite it. Okay. Different color. So from 2 more, I thought I changed the color. I'm sorry. There you go. Okay. So let's look at oxygen and carbon dioxide now. Okay. So according to the balanced chemical reaction, from 2 moles of oxygen, how many moles of carbon dioxide do we get? 1. With 2, we're going to get 1. Okay. So if that is the case, with 25 moles, how many moles of carbon dioxide can we get then? Anybody? So there's some math involved here, right? So the way you do that is this. With 2, you're going to get 1. Therefore, if you divide this 1 by 2, you're going to get how many moles you're going to get from 1 mole of oxygen. And then you multiply that by 25. Okay. And that would give you the moles of carbon dioxide you get from 25 moles of oxygen. That's going to be 12.5. Okay. So that's one way of doing that. There's another way of approaching this. If you don't want to think too much, okay, this might be a good option. Okay, so maybe I'm going to try to do that. Do we have any questions about this method first? Any questions? Yes, Millie. Yes, step by step. Yeah. So first of all, I look at the balanced chemical reaction. From the balanced chemical reaction, I say that to react with 1 mole of CH4, I need 2 moles of oxygen. Right? To react with 1, we need 2. To react with 25, which is what we have, we need 50. Right? So we need 50, but we only have 25, meaning oxygen is limiting because we don't have enough oxygen. So once we have the limiting reactant, we look at the relationship between the limiting reactant and what they're asking, which is carbon dioxide. With 2 moles, I'm going to get 1 mole of carbon dioxide. Therefore, with 25 moles, I'm going to get half of that, which is 12.5 moles of carbon dioxide. That's it. Yeah. So let's think about the other way now. I'm going to try to let me clear my doodling. Okay. So maybe I'm going to try this. Maybe it doesn't work, but I'll try it anyway. So let's think about this. So we know what is given. You are given 25 moles of oxygen, and they are asking for the CO2 moles. That's what they're asking. And the balanced chemical reaction is CH4 plus O2 gives us CO2 plus H2O. Okay. So when we balanced it, we got 2 and 2. I think this is the balanced chemical reaction. Okay. Now, we're going to always start with what is given. What is given is 25 moles of, I'm trying to do this without thinking too much. Let's see if it works. Okay. If it doesn't work, I'm going to go back. All right. We are given 25 moles of oxygen. Okay. But we don't want oxygen. What we need is carbon dioxide. So I'm going to get rid of oxygen. How do I do that? I'm going to divide this by the moles of oxygen. So I see that with 2 moles of oxygen from the balanced chemical reaction, with 2 moles of oxygen, I'm going to get 1 mole of carbon dioxide. 1 mole of carbon dioxide. Okay. So I'm getting rid of my moles of oxygen. I'm going to end up with units of moles of carbon dioxide, and then I'm going to get 12.5. This has a special name. I think it's called dimension analysis or something like that. Maybe you have used this before. Okay. This is another way of looking at it. This is a very simple version. And then in a minute, we're going to be looking at, how to use grams and stuff like that in the same way. Okay. So you start with what is given, and then you want to end up with what they want. So just all you do there. Have you done this, Millie? Something like that? Yeah. It's really simple. You don't think too much. Okay. Any questions, concerns, comments at this point? Okay. So and there's another point I could make here, but I don't know whether I should do it now. You know what? I'll show it to you now. Anyway. So let's say that you did not determine the limiting reactant. Okay. If that is the case, you have to do 2 calculations. 1, considering oxygen as your limiting reactant. 2, considering CH4 as a limiting reactant. Okay. So you are given, again, 25 moles of CH4. But you don't want CH4. So therefore, you're going to get rid of CH4 by dividing this by the moles of CH4. Okay. I say that from my balanced chemical reaction with 1 mole of CH4, I'm going to get 1 mole of carbon dioxide. So I'm going to write that ratio here. With 1 mole of CH4, I'm getting 1 mole of carbon dioxide. And then when you do if you plug and chuck the values here, you're going to end up with 25 moles of carbon dioxide. Okay. You see that if we use oxygen, you get a lesser number than if we use CH4. So here's what you do. You do these 2 calculations, and whatever the calculation gave you the lowest number is our limiting reactant. So this gave us the lowest number, and that is from oxygen. Therefore, oxygen is our limiting reactant. Okay. That's another way of determining the limiting reactant and doing the calculation at the same time. I just want to make that point. If it is too much, come back to this slowly. Okay. But now I will reopen this question, and I'll open another question for you. Oops. All right. By the way, this is not octane. This should be methane, pure methane. Methane is CH4. Now, don't overthink this. This is just asking you to determine the number of moles in a certain amount of grams. We have done this in multiple times in unit 1, module 3. Grams to moles. Okay. And the equation, if you can remember, is number of moles is equal to mass divided by the molar mass. That's all you have to do there. So mass is what is given to you. This is our M, 6.4 grams. Okay, 6.4 grams. Does anybody know the molar mass of CH4? 16, yeah. 16 grams per mole. I always write the units because it is so satisfying to see how the units cancel out to get us what we need. Okay, so you see that grams cancel out, you're going to end up with moles. All right, I think there should be enough time for this question. Okay, I'm going to close the question in 5, 4, 3, 2, and 1. All right, most of us got 0.4, and that's the correct answer as well. 6.4 divided by 16 is 0.4. All right, do we have any questions, concerns, comments about that? All right, that was just a reminder of what we have done before, okay? Now, let's try to use this information in our stoichiometric calculations. Uniform module 2, stoichiometric calculations, that's what we're doing now, okay? So let me clear my doodling one more time. I am going to need my balanced chemical reaction, but I'll write it for you. Same reaction. Right, CH4 reacting with oxygen to produce CO2 and H2O. 2 and 2. Yeah. You can use either method that that works for you. You can either determine the limiting reactant first and then calculate what you want, okay, using that. Or you can do 2 calculations with both reactants and see which one gives you the least number, the lower number, and run with that. Either one is fine. So, okay, I'm going to close this question in 5, 4, 3, 2, and 1. Okay, so let's see. What is the mass of carbon dioxide that will be produced if 20 moles of methane was burnt in 30 moles of oxygen? All right. Now, once you're familiar with what's going on, you can see that with 1 mole of CH4, we need 2 moles. Therefore, with 20 moles of methane or CH4, we're going to need 40 moles, but we only have 30. Therefore, oxygen is our limiting reactant. Okay. But even if you don't do that, and you can still use this method to do this problem this way. Let's do it. Okay. I think this is enough space. All right. What is given is 20 moles of CH4 and 30 moles of oxygen. Right. And what they're asking is it carbon dioxide? I forgot. Yeah, it's carbon dioxide. Yeah. They're asking for mass of carbon dioxide. All right. So I would do this. I would figure out what is given and what they are asking, first of all. Okay. So that we know where we are at and where we want to go. Okay. So let's start with 30 moles of oxygen, right? So we have 30 moles of oxygen. I'm trying to think less here. Okay. So we don't want moles of oxygen, so I'm going to get rid of that. Okay. How do I do that? So I'm going to use the molar ratio from the balanced chemical reaction, right? So with 30 moles of oxygen, so yeah, here's the balanced chemical reaction. I was looking for this. All right. We are looking at oxygen and CO2. With 2 moles of oxygen, I'm going to get 1 mole of carbon dioxide. So why did I do that? To get rid of oxygen moles, because I don't want oxygen moles. I want grams of carbon dioxide, but I cannot go directly to grams of carbon dioxide. I have to follow the steps to get rid of the other units. Okay. So I did that. Now, if I do that, I'm going to end up with the moles of carbon dioxide, but I don't want moles of carbon dioxide. What I want is grams of carbon dioxide. Now I know 1 mole of carbon dioxide has a mass of 44 grams. Okay, 1 mole of carbon dioxide is 44 grams of carbon dioxide. If I do that, okay, I can get rid of my moles of carbon dioxide, and I'm going to end up with grams of carbon dioxide at the top. Okay, that is what I decided to do. Okay, that's where I want to end up. Now, what I want to do is to use a calculator and then calculate this number. I don't have a calculator, but I need your help. So it should be 22. 22 times 30 must be 660. Is that right? 660 moles in the grams of. Okay, someone check the calculation. 22 times 30 is 660. Is it correct? Yes? Perfect. Thank you, Cadence. Yeah? So you have to always check my calculations because I don't have a calculator, as you know. It's very convenient for me. I want to keep it that way. All right. Now, we get 60 grams of carbon dioxide with considering oxygen as our limited reactant. Now consider the other case. In the other case, we have 20 moles of CH4. Okay, but we don't want moles of CH4. I want to get rid of that. How do I get rid of that? I'm going to go back to the balanced chemical reaction. With 1 mole of CH4, I'm going to get 1 mole of carbon dioxide, right? So I'm going to write that over here. With 1 mole of CH4, I'm going to get 1 mole of carbon dioxide. When I do that, I can cancel out the moles of CH4, and I'm going to end up with moles of carbon dioxide. And I don't want moles of carbon dioxide either. I want grams of carbon dioxide. So I know 1 mole of carbon dioxide is 44 grams of carbon dioxide. Therefore, I can cancel out moles of carbon dioxide as well. Now I have these numbers. If you use your calculator and crunch these numbers, you are going to end up with, I believe, 880. Is that right? Oh, yeah, you're going to end up with 880 grams of CO2. Now, between these two numbers, 660 is smaller. Okay, therefore, this should be your answer, and oxygen must be your limiting reactant, because limiting reactant gives us the lesser number out of the two. That's it, done. Okay. Yes, Thomas.
The limiting reactant in the reactant side, will they always have the high coefficient, or is that just?
No, it differs. So balanced chemical equation is a recipe. It doesn't tell you what is limiting. For an example, like the pumpkin pie example, right? So recipe tells you 100 grams of pumpkin and 300 grams of sugar. It doesn't tell you what is limiting. It's just a recipe on a piece of paper, right? What determines the limiting reactant is what you do when you go shopping. If you buy more sugar, or more than 300 grams of sugar, or less than 300 grams of sugar, and how much pumpkin you buy, that determines your limiting ingredient. Yeah? Huh? All right. So let's do one more. All right, here's a different reaction. Okay, finally, right? We get to play with a different reaction. Now, you can see that we went from moles to moles, and then moles to grams, and now we are in grams to grams. We are going from grams of reactants to grams of products, or actually the other way around. You're given the grams of product, and then you are asking how much of a reactant we need. One more time, use the method we talked about, all right? Think about what is given. Start with that. Always start with what is given. Okay? So I'll even write what is given. I forgot already. Okay. Anyway, so what is given is 216 grams of H2O. And they are asking the mass of C2H6. And then the reaction is when C2H6 reacts with oxygen, you get CO2 and H2O. It is not balanced, so you have to balance it. So you have 2 carbons. So I'm going to multiply carbon dioxide by 2. You have 6 hydrogens. You only have 2 here. You're going to multiply the H2O by, oh, you cannot see, I'm sorry. You multiply the H2O by 3, so that you get 6 hydrogens as well. Now I look at the oxygens. Okay, so I have 2 oxygens on the reactant side. We have 2 times 2, 4, plus 3, 7 oxygens on the product side, right? So if I need to have 7 on the reactant side as well, so I'm going to multiply this by 7, but that will give me 14 oxygens, not 7. Therefore, I'm going to divide this by 2. Now, this would give me 7 oxygens on the reactant side as well. Okay, but I don't want fractions, so I'm going to multiply everything by 2 to get rid of the denominator. I'm going to get C2H6, 7 O2s, 4 CO2s, and 6 H2Os as my final balance equation. Okay. Now it's easy. Yeah. So you start with what is given, which is, this is what is given. Given, this is asked. This is what is asked. Okay. So always start with what is given, 216 grams of H2O. But you don't want grams of H2O, you want to get rid of that. How do I do that? I know 18 grams of H2O has 1 mole of H2O. So I need something with grams of H2O in the denominator to cancel this out. But this will give me, so grams of H2O will cancel out, and this would give me moles of H2O. But I don't want moles of H2O. I want to get rid of that. Okay. To do that, I'm going to look at the balanced chemical reaction with to get 6 moles of H2O according to the balanced chemical reaction. To get 6 moles of H2O, 6 moles H2O, I'm going to need 2 moles of C2H6. 2 moles of C2H6 from the balanced chemical reaction. Okay. When I do that, guess what? I can cancel out moles of H2O. Now I'm going to end up with moles of C2H6. I don't want that either. Okay. I want to get rid of moles of C2H6. So I'm going to divide this by moles of C2H6. I know 1 mole of C2H6 is how many grams of C2H6? What's the molar mass of C2H6? 30, right? Yeah. 30 grams of C2H6. Now, when I do that, I see that most of C2H6 cancel out. I'm going to end up with grams of C2H6. Beautiful. This is what we need. Now, we just need to plug and chuck these numbers into a calculator. I don't have a calculator. You have to do it. Okay. So you need to write, you need to have 216 multiplied by 2 multiplied by 30 in the numerator, and in the denominator I have 18 multiplied by 6 because I avoided once, and this is going to be the grams of C2 at 6. Oh, this can be done without the calculator. You should do it. Okay, I'm going to just play with this. 3, 10. You should be divided by 3. 2, this is 6, this is 1, 2, oh, it's 120 grams. Is it right? Can somebody check? I got 120. Yeah. All right, that's it. That's all you have to do there. Yeah. I mean, you start with what is given and try to end up with what they're asking for. Done. That's all you do. All right, I think that's it. It's exactly 1:50. We are right on time. I already gave you the attendance code. So yeah, happy Thanksgiving, everybody. I'll see you next week. Yay. Yes, sir.